Hello students, can you hear me? Okay. Okay. So let's begin. Let's begin the session. So this is the new unit, which is unit 2, stratified random sampling. Stratified random sampling, unit 2. At the rate third October. So let us begin the new unit, which is based on the stratified random sampling. So let us understand first what is stratified random sampling. Okay. So to start the random sampling first, we need to understand few conceptual thing. So when you just start reading this, you will become understand what it means. So far we have seen when we have a homogeneous data, right? When we have a homogeneous data, right? So if I'm just partitioning this particular area into two parts, that means here the size is same, right? Here the size is same. Okay. So these plots are homogeneous. This is one example. Another example, if I'm considering all SYBSC students, all SYBSC students for doing any survey. So here I'm considering the homogeneous data. I'm considering the homogeneous data. So if I'm considering homogeneous data in my you can call survey, that means here I'm talking about simple random sampling. Here I'm talking about simple random sampling. But if my data is not homogeneous, that means my data is heterogeneous. Okay? So if my data is not homogeneous, that means you have to go by stratified sampling. So the important task is here to understand when do we apply the stratified random sampling. So stratified random sampling is applied when we have the heterogeneous data. Heterogeneous data, that means if I'm considering let's say height of students from you can say class, let's say class 1 to class 10. Okay. So if I'm assuming the data of students from class 1 to class 10, what are the heights? So the students at one his height is, let's say I can say you can say height, or you can say year, you can call how many year he is or she is. So the students in the class 1, his he may be year will be 6 year. Okay. So what will be their height? So we can measure their height. Similarly, if class 2, then 7 year, and what will be their height, and so on. So is there is a discrepancy between, is there is a change in the you can say height from the class 1 to class 10. So here I am assuming not homogeneous data. Here I am not assuming the homogeneous data, which is, that's why I'm going to use not simple random sampling. I'm going to use stratified random sampling. So this is the very important. This is the very important when we go for stratified random. This is the very important thing which you can just understand. So let us now understand the problem. How this problem can be. What is basic introduction. So an important objective in any estimation problem is to be obtain the estimator. Okay? So a very important thing is that we need to estimate. We need to obtain the estimator of a population parameter. Okay? Population parameter. which can be take care of the all silent features of the population. That means we can understand what will be mean. So what will be variance? That is all considered by the all things will be, that is your basically population parameter. If the population is homogeneous, so if talking about the population is homogeneous, like I have given the data of like this. So if you have a plot, if you have the same, if you are making same division, means the area is same. If I'm considering all homogeneous data like SYBSC students, FIBSC students, TYBSC students, they are all homogeneous data where we have a same type of students, their age approximate near to same, their height is approximate near to same, like that. Okay, so so those things will be considered with reference with respect to the characteristics under study. So that characteristics which we are assuming, that is the important. Then the method of SRS, method of simple random sampling, is will be useful. So whenever we go for homogeneous data, we know the method of SRS is very useful for us to understand the things, which is the homogeneous sample. Because why it is homogeneous? Because we have the same type of students, so the height will be the same. That's why that will yield the always a homogeneous data. And we found that the sample will be a good estimator of the population, and even if we have also shown that the sample mean is unbiased estimator of population mean and so on. Okay, but if the population is homogeneous with respect to the characteristic under study, so here one can say, if I am getting the homogeneous samples, I can say that the sample mean is a good estimator of population. But what happens if it is not homogeneous? Okay, so, so, so in that scenario, we can always go for simple random sampling, where because it is provided the proper results. But moreover, if you see that the variance of a sample mean. So even in the sample and SRS, we have seen that the variance of formula. What will be the variance of y bar in that case? The variance of y bar formula is something like, I can say n minus, I cannot say 1 minus f upon something like uh, small n into something s square, something right, like this formula. We have some formula. So one can see even under the SRSWR, the variance of sample mean is not only depends on the sample size, but also it is depends on sampling fraction. Okay, so this is your sampling fraction. So not only depends on these, and that is sample size, sampling fraction, but also it depends on the population size. You can see here population variance. Okay, so one can see here, the thing is that, so here what I mentioned not only depends on the sample size, sampling fraction, but only the population variance. So this is the one can say, when your data is not homogeneous, when data is not homogeneous, and then we are calculating the variance in the heterogeneous case, it will create a problem. Okay, so to get, so in order to increase the precision, right, in make to under to get the proper variance, to understand the proper accuracy in the variance of that particular estimator, we need to use the sampling scheme. Okay, which can reduce the heterogeneity in the population. So if you apply, even if your data is even if your data is heterogeneous, and you thought no it is not heterogeneous, and you have a find the uh, you have find their mean, so you have find their variance, the variance become larger. So in that scenario, it has a no role, and one can go with like saying ki the variance is very large. Okay, so we go with the SRSWR, then SRSWR, and like that. So in that case, one can say the variance is very large, and that data is not appropriate for doing analysis. So if the population is heterogeneous with the respect to characteristic under study, then one may use the sampling procedure, which is stratified sampling. So this is the very important. So whenever you go for the data where heterogeneous population is there, we need to always go for the stratified random sampling. So the basic idea behind that, what, how we can perform this stratified random sample, how we can go with the stratified random sample. So what we have to do in that case? Okay, so first you have to divide the whole heterogeneous population. Okay, so we have like we have this data, we have this data. Okay, so let's say I have this data. Oh, sorry. Like this is the entire population I have. Okay, and so this is called heterogeneous population. So this is the data I have, this is the data I have now, and these data contain all different ages like class 1, class 2, class 3, class 4, and so on. This example I have considered in maybe the coming session, so you can see that example. So we need to divide this data into smaller groups or subgroups. So I can say I will start dividing the groups. Okay, so I will say, like, let me create one group here. Okay. So this contain the class. So again I can divide into subgroup. Okay. So this is the data I have divided. So so if I'm considering the class of, let's say, 1 to 10, see, like we have a class of, okay, so let me just complete this and I'll move to the example part. So such a sampling, so we need to understand the heterogeneous. So if the data is heterogeneous, we can't use SRS. Okay, that fails them because it is heterogeneous. So we need to divide, we need to create a group, that is smaller group, or you can call subgroup, in such a way that your units become homogeneous. Units become homogeneous under study. Okay, so so within subpopulation. So suppose if I'm assuming this is my first population, this is my second population, third population, fourth population. So I have to just understand, these populations, this population which I'm assuming, this population has to homogeneous within, this is within. Okay, means under this category the population should be homogeneous. Under this you can say under this group, or you can call subgroup. Just a minute, I'm again starting. I'm just sharing the screen, one second. Yeah, so uh, so this is second group, this is third group, this is fourth group. Sorry. So the very important is that the sampling with the homogeneous with respect to characteristic within the subpopulation, within the subpopulation. So very important that in this population, in this group, we need to have a same, we need to have a same group, we need to have a same uh, data. You can say same type of weight, same type of, I can say, height, etc. Okay. And the heterogeneous, see, the heterogeneous with respect to characteristic under study within, sorry, between and among the subpopulation. So between 1 and 2 it will be heterogeneous, between 1 and 3 it is heterogeneous, between 1 and 4 it is heterogeneous, but within you must have, you must have homogeneous. And then, and see, and we are treating that population is a strata, very important, huh? So generally we call, this is one strata, this is another strata, this is third strata, this is fourth strata, and so this strata contain all populations, all subpopulation, all group which is homogeneous. Okay, again this contain all homogeneous. So if we have all homogeneous, now we can use SRSWR. So that is things I want to just introduce. Okay, and treat each population, treat each subpopulation separate populations, and draw the sample by SRSWR from each stratum. Okay, so stratum is a singular, and the strata is a plural. So if you have more than one strata, you can call that is you can call that is plural. Strata we generally call. Otherwise, if you have one strata, that you can call singular. that is called stratum. Okay, let's understand more deep about this. You can call stratified. So just understand this example. In order to obtain average height, so I'm interested actually in average height of a students of a class from class 1 to class 12. Okay, so I am assuming all the students in a class, in a school or in a college from class 1 to class 12, and the average height, I can say I'm interested on average height. Okay, so that is a very important part. You can call this is, you can call y bar, you can call it y bar. So I'm interested on y bar. So the height varies from, you can say, class 1 are around 6 years. Okay, so you can say, so maybe their age will be around 6 years. So those students having the class one, maybe around he is you can call 6 year. Okay, means approximate 6 year. And class 10, you can say approximate age will be the 16 year. Okay, so this is just approximate around the age I've considered. And so one can see 6 year and 16 year, large differences there. Large, you can say, discrepancy there. So it is called heterogeneous data. It is called a heterogeneous data. Okay, so one can divide all students into different subpopulations or strata. Okay, so here I have divided, here I have divided the data. uh, is it I have shared the screen? Can you see? uh, is it I have shared the screen? Can you see? Okay, now it is visible. Now are you able to see the screen now? Okay, okay. So it is very simple. You just understand. We have a, we have, even if I not share the screen, it is just understand. If we have a class 1 to class 10 or class 12 students in our school or in our college, can I use SRS? So simple questions to all. So it is not okay. So I'll let me unmute and then let us discuss few things, because it is just like reading, then it has no use to. So that we can interact. I think this is 20 minutes already done, so we can just interact and let me know. Okay, so I have unmute. So what I'm trying to say here, so here you can see we have a total class 1 to class 12 students data, and we have a approximate, there is their age will be the 6 year, and this is around 16 years. So one can see the class 1 approximate age will be 6 year, and class 12 approximate age is 16. So taking the data from the class 1 and then drawing the data from class 2, or can say class 12, it is basically a heterogeneous data. It is basically a heterogeneous data. So
Hello, sir.
yes, can you hear me?
Sir, can you repeat once again?
What you want to explain?
So the previous, uh,
This one.
yes, sir,
Yeah.
that's one.
So basically here the same thing I have, whatever things I have I'm explaining here now. Same thing is that which is explaining. So we have a heterogeneous data. So this is the heterogeneous data, right? Class 1, class 12, we have heterogeneous data. So these data will be divided into homogeneous data. Okay. So that homogeneous data, so within the data which you are dividing, the data should be homogeneous within the group. So if I'm considering the example of class 1 to 3, and which I'm saying the stratum 1. Now what is stratum? Stratum is a group of the data which are homogeneous. So see, stratum or strata or a group that are the list of person, list of students, list of, you can say, anything which are homogeneous. That is important. So here class 1, 2, 3 students will be considered as a one stratum. Similarly 4, 5, 6 will be another stratum. 7, 8, 9 one stratum. 10, 11, 12 another stratum, and so on. Okay. So what I'm trying to conclude here, we have different ages where I cannot able to use SRS. So in that scenario, my simple random sampling fails. Okay, and we have to go for stratified random sampling. So you need to create a strata. You need to create a strata, which is a group of person, or you can say group of things which are homogeneous, which are homogeneous within homogeneous. मीन्स अगर स्ट्रेटम 1 की बात करता हूँ मैं, तो उसके अंदर मेरा हाइट अप्रोक्सीमेट, इसका हाइट मैंने 6 बोला तो 6 7 8 मतलब अप्रोक्सीमेट मेरे को सेम हाइट मिलेगा. स्ट्रेटम 2 की बात करूंगा तो यू कैन से इधर 6 7 8 हुआ तो 9 10 11 मीन्स अप्रोक्सीमेट 9 10 11 के आसपास मेरे बच्चे सब रहेंगे, उनके यू कैन से एज अप्रोक्सीमेट रहेगा. स्ट्रेटम 3 में अप्रोक्सीमेट सेम एज रहेगा. इट इज नॉट गोइंग टू बी सेम बट अप्रोक्सीमेट सेम एज रहेगा. एंड once you have created a strata, we have to go to the unit 1. We have to use SRS for each strata 1 2 3 4 and draw a samples combined together with constitutes final stratified sample for further analysis. So this is the very important task which we are dealing with now. So the only task is that we need to create a data. We need to create a stratum. We need to create a strata. So how to create the strata, that is very important. And so once it is done, then you can use you can call using simple random sampling with replacement, without replacement, and you can go with that SRSW. So the next task become easy for us. Okay, is that clear or not? Let me understand first. Have you understood what is the meaning of straight? Uh,
Yes, sir.
Everyone can understand what is the meaning of stratified random sampling. So I am dividing the heterogeneous data into homogeneous. That is the task. So once you have divided the heterogeneous data into homogeneous, but only one condition is that the strata which I am dividing, it should be homogeneous within. मतलब ये स्ट्रेटा में सब जितने भी पॉपुलेशंस रहेंगे सब आपका सेम टाइप होना चाहिए. सिमिलरली ग्रुप 2 में सेम होना चाहिए. बट यू कैन सी देयर आर हेटेरोजेनियस बिटवीन. देखो आप डिफरेंस समझो. विद इन का मतलब क्या होता है, इसके अंदर जितने भी पॉपुलेशंस होंगे सब सेम होंगे, इसके अंदर जितने भी पॉपुलेशन होंगे सब सेम होंगे. बट 1 और 2 की बात करूंगा तो दे आर डिफरेंट. 1 और 2 की बात करूंगा तो दे आर different. So that is called between heterogeneous. So sometime in objective questions it may be asked, your strata should be homogeneous within subpopulation but heterogeneous between the population. Okay, so that is the very important task in stratified random sampling. Is that clear? Is that clear to all or not?
Yes, sir.
Okay, I can give another example. For example, suppose for example let me say you want to cultivation of, let's say, wheat. Okay, so you are cultivating some wheat or rice or whatever you can say particular things. Okay, so what are things are required for cultivation of wheat? Generally you require a good type of soil. That is very important. Okay, so what I do, I need to create a plot. Suppose I have a 1 acre plot here. This data I have. Okay, so this is my data. Okay, and I'm just trying to understand, this is my heterogeneous data. means I can do whatever I want to using this data. So this is my plot. This is my plot or area. Okay, which contain all soils are there. Which contain all soils are there, right? But I want to see whether this particular soils, let's say this area or let's say this area. Okay, let's say this area. So I have divided the data into homogeneous, which is important. So area from, let's say, this area, this area, this area, and this area. So I have divided the heterogeneous data into homogeneous. So they have same size. You can say approximate same size. Okay. So what now I'm going to do here? So here the soil is same. Here the soil is same. Here the soil is same. Okay. And I want to cultivate the wheat. Particular, I want to cultivate wheat or rice or whatever you can call, any plant you can call. Okay. So what type of fertilizer I'm going to use? So let's say here I'm using one type of, let's say, 120 kg of nitrogen. So 120 kg of nitrogen here I'm using. Okay. Then I can say here I'm using, let's say, 100 kg of I can say nitrogen. Here I'm using 80 kg of nitrogen. Okay. Here I'm using, let's say, 30 kg of nitrogen. Okay. So this is my all soil. This is my all soil. There are all type of, we can call, mitti is there. Okay. But I'm using the different quantities here. I'm using the different fertilizer here. Then I may give the water label here. Okay. Water label देंगे हम लोग, sunlight देंगे हम लोग. Okay. So what I'm trying to say here, the plot from one, within this under one, all are homogeneous. But if I'm saying between this one to two, here see, you can say I'm using the different type of you can say fertilizer, which is not, I can say nitrogen 120 kg. I can use phosphorus here. I can use potassium here. So here, and then I will try to see the height. I will try to see the height of particular plant. I can say, let's say, tomato height, or I can say rice. I can see wheat ka things. Okay, so I will measure their height. कि height यहाँ का ज़्यादा बड़ा है कि यहाँ का ज़्यादा बड़ा. So this is the way one can do the experiment, and they can try to use SRSWOR technique. So this is all based on simple random sampling, which is quite useful. Okay. And then one can go for, like, यहाँ पे मैंने कोई fertilizer use किया, and you can compare those fertilizer कि कौन सा fertilizer सबसे अच्छा है, मतलब कि कौन सा fertilizer हमको सबसे ज़्यादा weed देता है. Okay. And then you can recommend कि हाँ भाई चलो ये fertilizer, मतलब if you just put ये एरिया में अगर 120 kg नाइट्रोजन आप डालोगे, फास्फोरस डालोगे, तो आपको इतना क्वांटिटी यू कैन से प्रोडक्शन होगा. दैट इज ऑल टॉकिंग अबाउट नेक्स्ट यूनिट, which is regression and you can call the ratio. Okay. So if you use this one, then what will be the effect on that? Okay. So those kind of things will be there in the unit 2, but it is a part of, again, heterogeneous. So we have a data heterogeneous. I am trying to drawing homogeneous, which is called strata, and then I am applying SRSWOR or SRSWR. Okay, so this is like another example one can. So this is a very famous example which is used in the cultivation of any plant, maybe wheat, rice, etc. etc. I hope you are clear with these two examples. What is the meaning of can called uh, stratified. So very important that stratified का यही concept है कि you understand your data should be, we have heterogeneous data, and the data is divided into homogeneous, within homogeneous, and between heterogeneous. Two things you can always keep in the mind. Your strata should be within homogeneous and between heterogeneous. Only two things. Yeah. Any other question is there so far? Yes, बोलिए. Let me see the chat box. हाँ बोलिए, can you hear me? So is there any questions related to? So I can proceed. No problem. So let's me go to the notations. These notations we have already seen, so it will not take more than 2-3 minutes to complete me. We know n is the population size, k is a one factor which is comes in strata, and now you know what is strata, right? So at least you know knowing the term strata. So strata, when we have more than ones, where see this strata is also called group, right? But in sampling we call strata. तो strata में क्या होता है? स्ट्रेटा में बहुत सारे ग्रुप ऑफ पॉपुलेशंस होते हैं जो सेम टाइप के होते हैं. ओके, इट इज इन सेम टाइप ऑफ हाइट, same type of rice like column, right? Different type of rice is there, so that you can just click in the name. So there are same type of data will be there within same होता है, between अलग अलग, between, so strata 1 strata 2 they are different, but within strata 1 all type of students will be there, their height will be the same. Then if I am using Ni is a capital Ni, which is number of sampling unit in ith strata. Okay, so just notation. So what will be total n, which is summation of I takes value 1 to k and I. Okay, just remember this these things. Small ni is number of sampling unit to be drawn from the ni strata. Small n will be total. So मेरे पास n1 n2 ni. So where I taking value 1 to k. I taking value 1 to k. So I have a k. I can say I have a k sample data. I can have a k population data, or you can call strata. So you can see like this. So this is I think this will become simple for you. So I have a population. The population divided into again small populations, but they are in same. They are a same. I can say sorry. So within it is homogeneous, but between heterogeneous. Okay. So this is same. This is same. This is same. But total become summation of, so I think this you can not properly see. So this is equal to capital N is summation I takes value 1 to k n I. Okay, so this is the total of all population which turns out to be capital N. Similarly, I have n1 n2 nk. So if I am adding small n, this is going to be summation n r, where I takes value 1 to again small k. So this is the things. Now there is another sampling which is called cluster sampling, which is not there in your syllabus. So I will just introduce what is the cluster sampling. Now in stratified random sampling, the strata, I have already mentioned what is strata. Strata within should be homogeneous, but between or among should be heterogeneous. That we have seen, right? But in cluster sampling, see, in cluster sampling, instead of strata that we call cluster, उसको हम लोग cluster बोलते हैं, strata नहीं बोलते. अपना जो cluster होना चाहिए वो within heterogeneous होना चाहिए and among homogeneous. तो ये difference है इसमें और इसमें. इसका just उल्टा होता है. इसमें एक strata में सब same type के populations होते हैं. But cluster sampling में क्या होता है? Within heterogeneous होता है, मतलब एक cluster में different type के populations होते हैं, different type के samples होते हैं. Okay, so that is means it is just opposite. This is just opposite of this one. तो आपको ये एक ही याद रखना है, just remember this one, otherwise you will get confused. So just remember for this, and just remember for cluster it will be just opposite. Okay, so for a cluster we have within heterogeneous and between or among homogeneous. So that is the things you can just understand. And then we can go for a little bit what is this is all we have seen, but abhi now thoda sa we have to see in the terms of what you call stratified. So your y is a basically characteristic under study as usual. Yij is the value of jth unit in ith stratum, and we know I is running from 1 to k and j is running from 1 to n, a small sample. Y bar you can find, divide by capital N. Similarly, small y bar I divide by small n. But remember, here we have population, here we have a sample. So this is called as sample mean from ith stratum. This is called as population mean with the ith stratum. So अभी तक हम लोग we are talking about small y bars, capital Y bar. अभी तक हम इसकी बात कर रहे थे, right? So this is for whole population. This is for whole population. This is for whole sample. अभी मैं क्या बोल रहा हूँ, मेरे पास अभी स्ट्रेटा बन गया, मतलब स्ट्रेटा 1, स्ट्रेटा 2, स्ट्रेटा 3, लाइक जैसा हो गया स्ट्रेटा. तो मेरा पॉपुलेशन जो होगा वो y बार I हो जाएगा, मतलब y बार 1, y bar 2, y bar 3, like that. Only this much difference is there. That's why we are calling y bar I, where I taking well 1, 2, 3. Similarly, you can go with the sample, and where we know what is yij and total y bar कैसे निकालोगे आप? टोटल y bar निकालने के लिए तो y bar का फॉर्मूला क्या हो गया आपका, बिकॉज इट इज अ टोटल पॉपुलेशन, राइट? तो ये सबका पॉपुलेशन. So if I'm adding all like 1 upon n and summation y bar I, तो मुझे मिल जाएगा I taking value 1 to k. This will give the capital Y bar. So this is something like this, you can see. Okay. So 1 upon n summation ni y bar I. Okay. And this, if you simplify, this is one important result which we call population mean. So Wi is a ratio of your individual sample size, population size divided by grand population, and this is also known as weight of the ith stratum. This is Wi. Similarly, we have a sample variance that we will discuss. I think somebody joined. Let me see. No, no one is no one joined. So I will continue. No problem. So once they have joined, I will stop it. I'll finish till here. Then we can go with that. Okay. Anyways, any question is there? Any question is there? Yes. Any question is there?
No, sir.
So any difficulty in notations, you may take down. I think it is better you can start write it down these notations, because ये notations थोड़े कैसे है, अभी तक simple थे because we are not dealing with ing and everything. But now onward it is going to be difficult. Why it is difficult? Because we are introducing more suffix. Okay, so you will be get confused with the suffix. So don't get confused with suffix, so that you can start write it down.
Ajay sir, are you there?
Yes, madam.
I will call out the numbers, maths and stats accordingly. You can mark. Okay?
Yes. Yes. Okay.
Yeah, I will call up. 343,
Ma'am, I'm supposed
321. Yes, Rahul.
Ma'am,
What happened?
I'm supposed to write down that number.
No, you are supposed to tick. I hope you have written numbers from 401 to 432 in front of you. Madam had given the list, no?
अच्छा, Excel file. Let me just start.
अच्छा, अभी वो जाने दो, अभी नहीं. अभी तुम क्या करो,
हाँ.
401 से 432 तक के नंबर एक पेपर पे लिखो.
अच्छा.
और जो मैं बोल रही हूँ उसको टिक करो.
Fine. एक मिनट.
And you look for after stats numbers, and Ajay sir will look after mathematics students number. Okay?
Okay, fine.
Okay, I will call out number again. I'll start from beginning.
Okay, ma'am.
343, 321, 328, 339, 410, 317, 309, 331, 315, 416, 314, 405, 407, 402, 408, 415, 413, 426, after 426, 301,